Now that we know what a char is, let's talk about the string data type. The string data type is different from all the other data types that we have considered so far because it's not a primitive data type. It's actually a composite data type. It's more complex. It comes with more bells and whistles. It's not primitive. So what a string is, it actually is a sequence of characters. So when you have one character, so you would have char A, you would have them in sequence, and you end up with a string. So if I wanted to save my name, I would save it in a string variable. So the string type is so the type of the variable is string. That's the type, and here this is the name. Couple of differences that the strings have as opposed to regular variables. First of all, one thing that you guys should consider is that a programmer's best friend is Google. Google is very important. If you have a problem, you go to it, you search it, and you will find it no matter what language you're working with. Processing has this pretty cool website that you could go and look things up. So let's go to processing.org, for example, here. And I'm just going to go to references. Now under references, I've already said that all the functions, you can find them here. So it's a very helpful tool. Now, if we go here, you're going to see under data. So under data, there is Boolean, which we still have to talk about. We mentioned byte, char, color I haven't talked about. There's double, there's float we've talked about, int and long that we all talked about. For the purpose of this course, double and int, char and boolean are basically the main ones we deal with. Now if you look, and you notice that under primitive data types you don't actually see string. The reason for this is that string is a composite data type. Right? So if you look at composite data type, you see all sort of things that are complicated data structures. And we haven't done them yet. We'll do some of them during the term of the course as our programming gets more sophisticated. You see string down here. So if you click on string, you actually see sort of string explained, the syntax of the string, how it's supposed to be done, and some methods which are associated with this string, and we're going to talk about these in this video. So going back to the slides, we'll see an example of how a string can be declared. Notice that the string, the S is always capital, right? So it should be capital S, not lowercase s in processing. Here is some string declarations and at the same time initialization. So we initialize it at the same time. This is how strings are. This is another thing that how strings are different from other variables. So let's say I have an int A, and I have a string S. In the memory of the computer, A is going to hold garbage. So we don't have anything in A right now, and it holds garbage. S, it hasn't been initialized, but the cool thing about strings is that if they haven't been defined, if they haven't been initialized, they don't actually occupy memory. So technically, S would look like this. It would just be sort of like a beginning point. You haven't given it any data to hold yet. I could go and say S equals, and this is the same S. So I could go and say S and assign it to a string. Now I need double quotations. So I could say Sam, semicolon at the end. Now this is how my string is going to look. It's actually going to look like this. So I'm going to have SAM in these cells. So S is a character, M is A is a character, and M is a character. So it's a string, it's a sequence of characters. Each of these cells are called an index. So we're going to have index 0, index 1, and index 2. In programming, in most languages, including processing, you always start counting from 0. So here you're going to have cell 0, cell 1, cell 2, and better yet, you call them indexes or indices, each index. So this is index 0, that's index 1, and that is index 2. The size of the string is 3, right? So another thing, interesting thing about string is that you always need their size to see how much data they are holding. So let's go back to my slides real quick. Actually, so if we declare 3 strings here, we have name, digits, and phone number. The way this is going to show in memory, it's like this. So with name, you have James, so a character in each place. There's a space, so the space also occupies an index. And then you have bond. And here you have the size of the string. And the string length, you can obtain it using a method or a function, which is the length function in this case. And I'll explain this in a minute. Basically, string being a composite variable, composite data structure, it's going to have its own utilities. These utilities are referred to as methods or functions. Once you declare the string, you are able to invoke these utilities for that particular string. So let's look at length, for example. So if you have a string S, ENGG233, let's look at memory. This is going to be saved as, so you're going to have S. This is going to be saved as ENGG space 233. So that's what we're going to have. And here, this is our space. The indices are 0, 1, 2, 3, 4, 5, 6, 7. Now, if you want to know the size of a string, you basically get this S and use the dot operator. So the dot operator is very important. If you say s.length, you're making a call to this length function. When you make a call to this length function, this is going to tell you how long your string is. So in here, when we have size is going to store the value of the length of the string, in which case it's going to hold 8. You could store the length of the string in a variable, or you could simply so I should say or you could simply print it to the screen, and you could say println s.length, and you don't need anything to go in between the brackets. Let's go to processing. So I could have, so notice you always have to have a capital S up front. So I could have string S1, and I would initialize it to, let's say, anything. It could be, so anything could go between the two double quotations. So for example, I could even say my name is Mohammed. Semicolon goes at the end. Now here, if I want to know how large this string is, like what the length is, I could simply say println, and I would say s1 dot. So that's the so when I say dot, I can access the utilities of the string. So it's going to be s dot length. Don't forget you have to put the close and open and close brackets to denote that this is a function. And let's see. Let's run this. Oh, I've made a spelling mistake. So it's supposed to be length t length. So I should have noticed it when the color wasn't right. So I have length spelled correctly now. If when I didn't have it spelled correctly, we got an error. So now let's run this. All right, and the length is 19. So let's look at it. Say so. This is so we start from here. M would be index 0. So let's see how many we have. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So 19 characters there. Space also counts as a character. In fact, space has ASCII value as well. So all the characters have ASCII values. So let's answer the question, and I'll be back with more material. Okay, let's consider another example. So let's say we have string s1. And let's initialize it right away. Actually, I'm just going to use a different color. So let's just say S1 Sam. So right away, this is S1, and we're going to have Sam in here. It's going to be index 0, 1, and 2. Now, if you ever wanted to reassign the string, so if you said S1 now, and you make it equal to Jack, or you assign the string Jack to it, what happens is this thing is going to be gone. So it's gonna go away, and basically all of a sudden S1, it's going to be holding Jack, and you're going to have indices 0, 1, 2, and 3. And the size is 4. So basically, here we have reassigned S1 to this new string. I said earlier that we have that the string comes with a bunch of methods or functions. Basically, what we want to do, so I introduced length, and I want to talk about at char, and the rest of these you can look them up, or actually I'll revisit them at a later date. But at char is interesting too, because basically it gives you the char at a certain index. So if you had S and you put ENGG233 in, so ENGG space 233. So it's going to be index 0, 1, 2, 3, 4, 5, and 6. And if we made a character ch, and you said s dot char at 1. So this says char at index 1. So inside of ch, you're going to have n. And you know, if you printed this, basically n is gonna be printed. If you had another print ln, so let's say if you say print ln s dot char at 6, you're going to get 3. Now, you're going to have problems if you ever put an index here that doesn't exist. So if you ever try to do something like this, so if you said print ln s dot char at, this is char at, let's say 7, then you're actually going to crash your program. So this is what is known as a runtime error, because you are actually processing will catch this because you are trying to access memory that's not there. So the memory that you have is from 0 to 6. If you try to access an index 7, then obviously you can't access that. So let's show that on processing itself. So let's say if we have, let's just say if you have index, just make it Sam. So if I say print ln and I say s1 dot char at, and I say at index 1, then what should be printed is a, right? Because a is the index 1. What if I say, like, let's say something like index 3? Let's see what happens then. So we get an error, and it's really nice that processing is handling this error. In a lot of languages, this wouldn't be handled and your program would run, but then it would crash. It basically says single index out of bound. So this is an out of bound error. It's a very dangerous error in a way that it happens a lot. So you got to be really careful. The same thing happens if I try to access an index that is -1. Because again, there is no index -1, so we would crash. But if I go index 2, index 2 is completely fine, and I'm going to get M printed out to the console. So that's char 1. That's how strings basically work. Do some exercises with processing, you know, play around with it. After all, programming is a skill. You need to play around with things, try things for yourself, and it should start clicking in and it should start making a lot of sense. Thank you.